Hi and good morning to everyone. This is me Saima Khadim from Dawood University of Engineering and Technology, Sindh, Pakistan, working as a lab engineer in Department of Telecommunication Engineering and also a master student in Telecommunication Engineering. Before to start my presentation, I am very thankful to all the sponsors and organizers of the conference to give me opportunity to present my papers in third international conference on green computing and engineering technologies. Today I am going to present on a survey on cognitive radio network using artificial intelligence. These are the contents of my presentation. Introduction. As the spectrum scarcity has increased, dynamic spectrum access is considered to be a vital element of future communication. Spectrum can be divided into white spaces, black spaces, and gray spaces. Unlike static spectrum access, dynamic spectrum access can considerably solve the issue of imbalance in spectrum utilization. Cognitive radio defines the use of both licensed user and unlicensed user for dynamically accessing spectrum. Cognitive radio make the decision by sensing the both outer environment as well as internal parameters. Federal Communication Commission defines high throughput, minimum interference, and interoperability as operating parameters of cognitive radio. We have seen that IEEE 802.11 standard utilizing the television white spaces for a wireless region area network. As the need for higher bandwidth will increase and simultaneously number of wireless devices arises, so the importance of cognitive radio will also increase. Cognitive radio has the ability to improve capacity and spectrum access. The cognition, that is learning and reasoning ability of cognitive radio, is provided through a number of ways, but one of the most popular way of providing this cognition is implementing machine learning techniques. Cognitive radio can be used in various applications like spectrum market, grid communication, public safety, femtocell, self-organizing networks. These machine learning techniques enable a cognitive engine to make accurate decisions, saving time and power and making the system more reliable. Artificial neural network is one of the most widely used machine learning technique for cognitive radio. We will discuss how artificial neural networks support cognitive radio, its comparison with other machine learning techniques, and several algorithms proposed by various authors that improves the performance of artificial neural network. Artificial neural network. Artificial neural network are computational tools inspired by brain's working of neurons. The idea was first presented by the neurophysiologist W. Michello and the logician W. Pitts in 1943. ANN are provided with input and output data. Then they are trained mapping input to the target output. The neurons are arranged in three layers: input layer, output layer, and the hidden layer. Artificial neurons gets input from all neighboring neurons and then adjusts itself depending on weight and activation function. Each neuron produces its single output value by accumulating input from other neurons. Learning of artificial neural network is achieved till the difference between the required output and output of network is negligible. Artificial neural network is a non-linear function with flexible parameters to give required output. Artificial neural network has the ability to learn different patterns, features, and attributes. By learning, the neurons' output are systematically adjusted and they can give results for new condition or data set. Artificial neural network has been used in spectrum sensing for cognitive radio. Different training methods and configuration types of artificial neural network. Few types of artificial neural network with cognitive radio are as under. Number 1, multilayer perceptron neural network. It consists of layers of neurons connected to previous layer output in linear combination. The weights are randomly chosen and then adjusted to give accurate results. For adjusting the weight, methods like genetic algorithm or backpropagation can be used. Second one is neuron perceptron network. By introducing nonlinearity in the network, we can make the network adapt the sample test. This can be achieved by cross multiplying two inputs or squaring inputs. However, for training weights, backpropagation can make the network slow by increasing processing time. Radial basis function network. Perceptron network have the problem of settling into local minimals. This problem is resolved in RBN, which has the distance criteria with respect to center in its hidden layer, its radial nonlinear function, which can be Gaussian, Euclidean, or any other. For training, gradient descent method is used. Cognitive radio and artificial neural network. Studies have shown that certain parts of a spectrum are overutilized while others are underutilized. In case if primary user does not uses a band of frequencies in certain region or time period, it creates a spectrum hole, and cognitive radio exploits this availability by using it as secondary user. In reference number 21, Hyken defined that two main objectives of cognitive radio are efficient utilization of spectrum and ensuring reliable communication. In reference number 23 and 24 defines a cognitive engine with its cognitive core performing all the learning and reasoning tasks. CR should be equipped with learning and reasoning ability. This learning and reasoning requires artificial intelligence techniques. Various artificial intelligence techniques include neural network, fuzzy logic, hidden Markov model, and genetic algorithm. Through cognitive reduced technique of dynamic spectrum sharing are developed for efficiently using crowded frequency bands. In recent years, research has done on applying machine learning technique on cognitive radio. Machine learning technique models, these are the some machine learning models. A neural network based spectrum prediction scheme for cognitive radio, and their authors are Vamsi Sharma, Tamuliro, Ping Wang, and Dusit Nyato, which is published in 2010. Authors use the MLP algorithm for spectrum prediction, which improves the spectrum utilization and reduces the sensing energy. Second one is learning based primary user activity prediction in cognitive radio network for efficient dynamic spectrum access. And the authors are Anirudh Agarwal, Shivangi Dubey, Mohammad Asif Khan, Ranjan Gangopade, and Sumitra. Learning Base, which is published in 2016, to provide an ideal slot, time, or unused spectrum to the unlicensed user by using machine learning technique. Four supervised machine learning technique, two from artificial neural network and two from support vector machine. Next one is channel state prediction in a cognitive radio using neural network using Levenberg-Marquardt algorithm, and the authors are Pavitra Roy and Dr. Muralidhar, which is published in 2015 to predict the ideal slots in the channel, which is based on the past information and then allow cognitive radio to select best slot for data transmission. For ideal slot prediction, neural network Levenberg-Marquardt algorithm is used. Next paper is performance evaluation of neural network based spectrum sensing in cognitive radio, and the authors are Rahul Singh and Sarita Kansal, which is published in 2016. The goal is to increase the decision accuracy in the presence of noise in the environment for secondary user by using neural network based spectrum sensing. Neural network is an intelligent or smart technique to predict the unused spectrum. Next paper is channel status prediction for cognitive radio network, and the authors are Vamsi Sharma, Vamsi Krishna, Tamiliro, Ping Wang, and Dusit Nyato, which is published in 2010. Two techniques multilayer perceptron hidden Markov model for spectrum prediction. The advantage of channel predictor is that these do not require prior knowledge of the channel. Compare the accuracy of multilayer perceptron hidden Markov model. Next one is artificial neural network based spectrum recognition in cognitive radio, and the authors are Rahul Singh and Sarita Kansal, which is published in 2016. The basic purpose is to increase decision accuracy under the various noisy condition, and it have implemented by using multilayer perceptron neural network. Next one is conceptual neural network based spectrum prediction for cognitive radio, and the authors are Masid Jolanta Mizira, which is published in 2015. Conceptual sigma if neural network is used to predict the status of channel or spectrum status for cognitive radio. From the simulation results, it is concluded that the conceptual sigma if algorithm is slightly better than multilayer perceptron neural network for prediction, and also it reduces sensing time for prediction. Next one is comparing performance of multilayer perceptron and Radial basis function neural network for TV, ideal channel prediction in cognitive review, and the authors are Unch Winston, Ufulo Thomas, and William Okello, which is published in 2013. Compared the performance of two most popular neural network algorithms, multi-ray perceptron and radial basis function neural network. The mean square error value of MLP is 0.0666 and mean square value of RBF is 0.083526. So, from the simulation results, author concluded that the MLP is slightly better than RBF. Conclusion: by artificial intelligence, we can achieve our goal of spectrum prediction, which is vital for cognitive engine. Among various machine learning techniques, artificial neural network stand out to be the most useful technique as it does not require much prior knowledge of the system to make decisions. Implementing of artificial neural network adds complexity in the system, but by certain modification in the ANN system makes it more accurate. Perceptron neural network is more accurate than Elman or feed-forward neural network. Its accuracy is higher than the RBF or other popular machine learning techniques like HMM, hidden Markov model. While neural network Levenberg microalgorithm perform even better than Perceptron neural network. These are the references. Thank you.